Hello, everybody. It is Friday, September 6th, 2019. This is the AWS biweekly meeting, Kubernetes AWS biweekly meeting. I am your moderator, facilitator, Justin Santa Barbara. I work at Google. A reminder that this meeting is being recorded and will be put on the internet shortly. And so please be mindful of our code of conduct and be a good person. I have pasted a link in the chat to the agenda. We have only a couple of items on there, but please do put your name in the attending list, and if you have any items you would like to talk about, please add them to the agenda. Otherwise, we can hand over to our first very exciting agenda item, which is Micah. You have a demo for us.
I do. So we're almost there.
Oh, well, if you want a little more time, we can go out of order if you prefer.
Yeah, Nick, if you want to go first.
Yeah, mine's, it's a very quick update. I was just going to say that yesterday merged, actually, yeah, I guess yesterday we merged the 0.1.2 release of the app mesh controller, and it adds initial cloud map support. So you can basically, your pod endpoints can be registered with AWS Cloud Map, which is a type of service discovery. And App Mesh uses Cloud Map to basically tell the envoys that it manages about those endpoints. So instead of using kubedns or coredns as your service discovery, you can use AWS Cloud Map, which is pretty cool. So that's it. It's merged. I think we still need to add some documentation on how to use the Cloud Map support to the repo. But other than that, you can start using it right now.
That's awesome. Thanks. Do you want to give a 30-second description of what App Mesh does?
Yeah, absolutely. So App Mesh is a AWS service, and it's sort of, I think of it as sort of an Envoy config generator. So it's a fully managed service that generates Envoy config. Envoys are L7 proxies, so you can run them as sidecars to your containers. And those, if you're not familiar with Envoy, it gives you basically metrics on your applications, so you get some observability and client-side load balancing and mutual TLS and stuff like that, so that you have a little more control over kind of observability and operations of the applications. And so App Mesh is this service that you create resources in App Mesh, and those resources are translated into Envoy config for you. So you declare your backends for each service. App Mesh will generate the config, send it down, and then your services, your applications can talk to each other. Does that make sense?
That's great. And this is for layer 7 inside the cluster. And does it do like layer 7 ingress, or is that where we go to ALB and things like that?
I think you can configure ingress, but it's, I think right now we don't really support it. So I would say you would go to ALB for now, but that's something in the future.
Awesome. Thank you for the description. And yeah, that's really helpful and exciting. 0.1.2. Micah, we hand the floor to you.
I'm ready. Okay, let's share my screen really quick. See if it shares the right screen. Okay, yeah, desktop 1. Share. All right, you can see my screen?
Yes, the text is readable, but probably, yeah, a little bit bigger for the recording.
Let me make that a little bit bigger for you. So what I've got here for the demo is just a really, really simple example. So I've got a config map I'm going to mount into my pod just as a example, but I'm mounting one thing just for a second part of the example, which is an AWS config file. But also this primary script is what's going to get run in the pod. So this script is just installing the AWS CLI, echoing out a projected identity token, and then calling get caller identity. So to give just a little bit of background on what will be going on here, the feature that we just launched this week for EKS and for even non-EKS, just AWS clusters or even non-AWS clusters, you can actually run this in a Google GCP cluster or a GKE cluster or just about anywhere you want, where the cluster has a public identity document. So what this does is you run this webhook in your cluster. For new EKS clusters, this comes built in. In the EKS case, you can describe your cluster, and there's a new field on the cluster description called the OIDC discovery endpoint. This endpoint is a URL that contains OIDC metadata, and one of the key pieces is the signing keys for projected service account tokens. Kubernetes has two types of service account tokens. There's the legacy service account tokens, which you're probably familiar with. This is what gets auto-mounted in every pod. It's for the pods to talk to the API server and authenticate that way. Those are static tokens. They don't expire. You can delete them, and that the service account token controller recreates them. But it's really difficult to migrate, rotate the signing key for those. You'd have to add a new signing key, delete all the existing tokens, which could be really disruptive, and then get all new tokens issued with a new key. It's a long process that nobody really ever goes through. The new type of service account tokens, the projected service account tokens, are temporary, and they're actually OIDC valid JWTs, JSON Web Tokens. They support configurable audience. So legacy service account tokens can only talk to the Kubernetes API server. These projected service account tokens can talk to the API server, but they can also be used to talk to other systems. And in this example, we're using them to talk to AWS. AWS has had since like 2014 this concept of external identity providers. So you can have your either SAML or OIDC provider allow users to authenticate to AWS without having to create an IAM user with password for every user. So you could make it a Google, Okta, whatever. But since it's just OIDC, and Kubernetes supports doling out OIDC tokens, we can put these two things together. So in this example, I have a Kubernetes cluster that I just created yesterday, and this is the token issuer endpoint. So if we look at this actually really quick, known OpenID configuration, we can see the OpenID config. Oh, it's not working. Yes, there we go. And if we go to the keys endpoint, we can see here's it's a RSA signing key. So this is just for STS, Amazon's Secure Token Service, or any other provider or any consumer of these tokens to see when I get a token, is it properly signed? Embedded in the token is this URL to say, go look up here and see if this is actually signed by the correct key. So that's kind of by way of background. That's just to let you know kind of what's going on in the back. So Kubernetes is now issuing these tokens saying, look here for validating them. And the key configuration in Kubernetes is you can add a new volume type called projected volume token, and it mounts one of these tokens into the pod. Now there can be a lot of configuration to set that up. So what we've done to make that a little bit easier is added a new webhook to our EKS clusters, and you can run this webhook in your own cluster. What it does is when a service account is annotated with an AWS role arm like this, and you given a certain pod like this, every pod create will be evaluated to say, what's the service account on it? Look, the webhook will look up the service account, look for an annotation. If the annotation is present, it will add the following environment variables: AWS role arm and token identity file. So you can see those two here. And then also a volume mount. So creating this whole configuration of a projected volume token. You don't have to use the webhook if you don't want to, and the annotation. You can add the environment variables and volumes to your webhook. If you don't want to use the webhook at all, that's fine. The webhook will short circuit if you've already added them and you've annotated the pod. And so there won't be any adverse reaction going on. But that's basically what I'm going to demo. So the other point is every AWS SDK at this point has been updated with support for these two new environment variables. So if the SDK detects, I see AWS role ARN and web identity token file, instead of going to the node level instance metadata, I'm going to call STS assume role with web identity. It's an existing API call to get my credentials instead of doing, IMDS, environment variables, AWS config file, etc. So let's see how that works. So back to the demo, I've got a script I'm going to run, install the AWS CLI, echo out or cat out the current token file, and get caller identity. And I'm going to create a service account token with this role ARN. And one other key piece is there's two directions in the trust here. On the service account, I have to say which role I want to assume, but also on the role itself, I've edited the trust relationship to say I trust this issuer, and I'm going to actually lock that down even further to say that it needs to be for a specific service account. So if I go back, actually add this condition policy to my IAM trust document. Let's remove that guy. I don't need this. I do need to scope to subject. I don't need to scope it to the namespace. Let's go here. And I'm going to add this really quick. This is a live demo. And this my service account is what we called over there, AWS, sig-aws, IRSA demo. So we're saying that this role can only be assumed by the specific service account. If I didn't add the string equals, then any service account in the entire cluster could assume the role if I wanted that. So I've tightened that down now. So if we go back to this, and then the last thing is, okay, we're creating a deployment. We'll just have one. It's going to run the script on entry. It's the Python 3 image, really simple. And we're mounting that script as a config map. So can you all see my screen? Is that big enough now?
Before you apply it, Micah, do you want to not print the token, or is the token okay?
It's a good point.
I don't know who's on this call. Let's see.
Yeah.
It's only an hour,
I'll
right? I presume, or something.
Yeah, that's probably a good call. I'll echo it. I'll stop that. I usually do that just for inspection because it's kind of fun, but we'll remove that. So we'll just get caller identity. All right. So deployment. The token is revoked as soon as the pod it's bound to is no longer active. So.
Oh, okay.
But yeah, we'll go ahead and remove it anyway.
Okay.
I guess that's only on the Kubernetes side. AWS doesn't necessarily know. All right. So we're going to create this really quick. So this will create the config map, the service account, and the deployment. So now we have all three created. Let's get pods. Is that pod ready yet? Okay, it's running. And we'll get the logs out of it. And we'll see that the identity in there, okay, it's still installing AWS CLI really quick. Project service account token, we're not issuing that out. Okay, access denied. That's probably the string equals. I just tested this without that. I probably worked this condition really quick. So let's remove the condition. Let's update that. It's going to restart, and we can actually just follow that again. Or I might have to delete the pod. We'll just delete the pod. Get a new one.
It looked like there was a cool trick in your JSON where you have a document comment in there. I don't know, is that valid?
It's just a hack on JSON that I don't know if I haven't actually tested to see if STS ignores those dot comments.
Yeah, that's what I was wondering, whether that would be a great feature. Yeah.
A lot of Go and Marshall will hold on. The Go JSON library will by default ignore fields it doesn't recognize. So for Go, it works really well, but for not every other system, it necessarily works. So let's try this again. So this should be installing the CLI, and then there it is. Okay, so what we have is the role that we wanted. So that's the S3 reader role. And then the AWS CLI is using Boto Core underneath, and it generates an automatic session name. If I were to actually do this again, if I go to my deployment YAML, and I were to uncomment this annotation, we'll see that that's actually a different role. So it'll be the underlying node role. And we'll need to delete that pod. Just delete all pods because there's only one. And get all pods again. There's our new pod. We'll trail that. Okay, so now you can see it's using the node instance role. It's using the instance metadata. The instance metadata is still on by default in the EKS AMI. It's up to you to sort of block IMDS, instance metadata, access from your pods, because during a migration period, if you're using the node role for everything, that's up to you to determine where that would come in. But that's kind of the demo. I can show one more thing.
Hey, Micah, I'm not sure if you addressed this earlier, but I note that you are executing this demo on a 114 EKS cluster. There isn't anything specific about the webhook that requires 114, is it? Is there?
There is not. It's the webhook actually, I think, works with even Kubernetes 112, like upstream Kubernetes 112.
Okay.
For non-EKS, docs are forthcoming. I'll be adding that to the webhook repository. If you're using 112 or even 113 or 14, a RSA key a second RSA key, you'll have to give the API server, private key and public key, because it uses the private key to create the tokens. These projected service account tokens, one of the key differences is they're not stored in etcd like legacy service account tokens, where you can get them as secrets. So not only are they short-lived and they automatically rotate, so the kubelet will remount a new token before it's expired in the pod. But they never hit the database. So they're ephemeral. All right. One more thing. Okay. I'll want to recreate this pod one more time. There's one more thing I want to show. So this works great for directly assuming a role, but a lot of users who are using cube to IAM, KIAM, etc., want to do chained assume roles. So I have a role in one account, or a second role in the same account, or a role in a second account, and I want to actually use that other account role within my pod. And that's totally possible via like sort of two primary ways. The first is just how I created an OIDC provider in my account that the cluster is in with this URL. This URL I can and it's a per cluster URL. I can easily create that same identity provider in my other account and have my pod, the annotation on that pod, directly assume a role in a second account. There's nothing specific in my cluster that's binding the pods necessarily to my account, right? Or the service account provider. So that's one way. The other way is you can do a chained assume role. So that's what I just want to show really quick. So if we get pods again, so we'll have a pod that's now annotated, it has the token and everything. Okay, so if we go in here, we shell into the pod really quick. So I've already have a config file, AWS config file, and it's got 2 roles in it. It's got, the first role is the one that I want to assume with this web identity token. The second is another role. It happens to be in my account, but it could be in any other account. And the second role, so 2 things. The first role, I'll show this really quick, has 2 permissions. It can list buckets. And it has a second permission that it can assume the second role. It can call SES assume role in the second role. If I go to that second role really quick, should go back to roles. I can highlight and show how this works. So the second role has a trust relationship that says my account ID can assume it. It doesn't have any permissions by default. It's just a demo that the role can be assumed. So if I unset AWS role ARN, all right, so there's no token file here, or is it mounted? Hold on. Oh, it didn't get mounted. I think I missed the annotation. All right. Well, that's how it works. I won't keep everyone waiting. I know it does work. And if you want to wait 1 more second, I'm sure we can get this working.
I think this is really great.
Okay.
Regardless of the complexity of chaining rules, I think it's great to have pod identity in there. I think yes, a lot of people have developed their own solutions, and this feels like a more secure option because of that additional annotation on the IAM side, AWS IAM side.
Nope, not what I wanted. I will get YAML. So we want to see that the volume is there. So we'll just double check that volume is there again. We've got our new pod, and you can see, okay, it has a projected volume token. Get the pod name. That's the label. The name's what we want. Okay, cool. Oh, did I not move? Copy. Oh, can't write it.
We don't need to put you on the spot, Mike. I'm sure you could put a video up of this and link it to the repo.
Yeah,
it's the watch shot, right?
It is. It's so I wanted to just demo the role, but you know what? We can do. Yeah, we'll have to do it another time. I have not thoroughly prepared this demo. It was tried to just show it quickly, but we'll save everyone's time for that.
The first it was awesome, and I think having the it was. I'm sure it works. It's just yes, it's great to see. I don't know if anyone else has any questions or anything like that for Micah, or everyone is just too busy downloading it to try it.
I have a quick question. This is Mike.
Yeah.
I'm with Adobe. You had mentioned Cube to IAM and different migration paths. Is this compatible where it can run at the same time as Cube to IAM as if we were to be switching from Cube to IAM over to this method, or would they conflict with each other?
I haven't tested it. I'm not sure. I think Cube to IAM, if Cube to IAM impersonates the instance metadata, then this should work fine, actually. This should just, most SDK, for SDKs, the web identity, assume role with web identity flow is before the instance metadata. What you saw here, the instance metadata was still enabled. And if the token file environment variable wasn't present, it fell back to instance metadata. So this should just take precedence over that, and it should be a fairly easy migration.
That sounds great. This is really cool. I'm very impressed and happy with what I've seen.
Awesome. Okay, we have the config. Okay, so we're getting the first profile, get caller identity, which is what we expect, S3 reader. Now we'll try second. There we go. So you can see it used the first role to assume the first role, and then using that credential assume the second role. So that's all I wanted to show.
That is really great. And yes, the point about the compatibility is also an awesome observation. That this is, yeah, you can get there one pod at a time or one deployment at a time.
So Micah, besides some of the documentation things that you mentioned earlier, is there anything on the sort of roadmap for changes or enhancements to what you demoed here today? Anything upcoming that you'd either like contributions from the community on or feedback?
Yeah, I think at this point, we're kind of just like excited to see people using it and see what new needs people have. I think this will solve like a lot of use cases. I think as those needs develop, like I'd love issues on the GitHub repo and contributions as well. Like I want this to work really well on like all cloud providers, so that if you're running this anywhere, you could use this webhook to get a token and talk to AWS.
Awesome. Yeah, I have now forked the repo, and you'll start seeing some PRs from me with doc updates and stuff.
Awesome.
Very impressive. Thank you, Mike. I don't know if there's anything else which anyone has added to the agenda, because I think we have reached the end of our agenda. I don't know if anyone else has anything they would like to bring up. Otherwise, everyone gets 30 minutes back. Going once, going twice. All right. Thank you, everybody. Thank you, Micah, for the
awesome
great
work,
demo. Thank you,
Micah,
Nick, for the update. And see everybody in 2 weeks.
See ya.
Bye.
Bye.